to start the chapter Measures of Central Tendency. Central tendency gives a single most representative value in a given data set. If there is a data given to us and we want to know in that series or data which value is the most representative or which value can represent the entire series, then that value shows the central tendency of the series. Central tendency indicates where the center of the distribution tends to be. It gives the answers whether the scores are generally high or generally low. Once we know which is the representative value of the series, from that we can compare the other values of the series in order to find out which are the values that are higher than the given representative value and which are the values that are lower than the representative value. The most commonly used measures of central tendency are mean, median and mode. First of all, let us discuss about arithmetic mean, or which we commonly call average. Definition of mean. Mean is the sum of all the values of an observation divided by the number of observations. Mean is the sum of values upon number of values. Its mathematical representation is in the form of x bar is equal to sigma x upon n, where x bar means arithmetic mean, sigma x means the total of the number of values that are given in the data, and n is the number of values, which means that sigma x is the addition of all the values that are given to us, and n represents the number of total values that we are having. Now we should understand how in different series we calculate mean. First of all, we are going to learn how to calculate mean in ungrouped data, that is individual series. The formula is x bar is equal to sigma x upon n, where sigma x is the sum of all observations and n is the number of observations. To explain this further, let us take an example. Let us find arithmetic mean of the following data: 12, 56, 31, 22, 25 and 39. Using the formula, let us first add all the values of x: 12 plus 56 plus 31 plus 22 plus 25 plus 39. This comes to 185. The total number of values is 6. So x bar or arithmetic mean is equal to 30.83, or it is rounded off as 31. So in the given ungrouped data or individual series, when we calculate arithmetic mean using direct method, we come across the value 31, which represents arithmetic mean. Next, we need to learn how to calculate arithmetic mean in a group data using direct method. Now, about ungrouped data, let us know a few facts. That ungrouped data or a data which contains frequency can be of two types. First, in which there are class intervals, and the other which is without class intervals. The one that is without class intervals is known as a discrete variable or discrete series. So first of all, we are going to discuss the calculation of arithmetic mean in group data, particularly discrete series. In this example, we have taken the values of x as 3, 4, 5 and 3. Frequencies are 2, 1, 3 and 2. Using the formula sigma fx upon sigma f, let us first calculate fx. So 3 into 2 is 6, 4 into 1 is 4, 5 into 3 is 15, and 3 into 2 is 6. Sigma fx is the total of the third column, which comes to 31, and sigma f is the total of the second column, which comes to 8. So 3.875, or rounded off as 4, is the mean in the discrete series using direct method. As I told you that ungrouped data, the second type of ungrouped data, can have class intervals, which means that the second type of ungrouped data can be a continuous series. For calculating mean using direct method in continuous series, we have to first of all find out the midpoints or the mid values of the given series. Let us take an example. In this example, there are class intervals given as 0 to 5, 6 to 11, 12 to 17 and 18 to 23. Frequencies are given as 2, 5, 7 and 6. First of all, as I told you, we are going to find out the mid value or the midpoint. How do we do that? We add the lower and the upper limit and we divide it by 2. The first example, 0 plus 5 divided by 2 is 2.5. Accordingly, we are going to calculate the mid values of all the given class intervals. Once we have calculated the mid values, we will treat them as x, and the next step is f into x. So we are going to multiply frequencies of individual classes into their midpoints in order to get fx of that particular class. After calculating fx, 2 into 2.5 is equal to 5, 5 into 8.5 is equal to 42 and so on. We are going to add the last column fx and we are going to get sigma fx, which is equal to 272. This we are going to divide by sigma f, which comes to 2 plus 5, 7, 7 plus 7, 14, 14 plus 6, 20. So 272 upon 20 is 13.6. We can round it off as 14. So this is how we calculate mean in case of group data, particularly continuous series, using direct method.